Hey YouTube, what's going on? A level now. Yes, not GCC A level. So this was done by the urgent request of one of my students who's struggling with kinematics vectors, and I decided to clarify some details. Unfortunately, it's not a pick of the week because it's too early and probably takes a bit more than 5 minutes. Okay, but let's get started. So guys, new subscribers, please welcome, try to show your skills by solving that problem. Okay, so this is about applied math to physics because that's mechanics, a topic within the math A-level math syllabus. And let's get started. Grab your pens, grab your notes, let's try to solve. We have two objects A and B which are moving on a straight line with constant velocity given below. Okay, we have the straight lines, and also the next fact is that a constant velocity, because velocity is the vector. It's a vector quantity in physics and in applied math as well. So we understand that constant velocity means no turning, no change in direction as the vector, and no change in the magnitude as well. So that's why velocity as the vectors stays the same. You might see here 59 and 20j in components form. There is no dependency from time, so that's why they definitely constant. Those words might be skipped actually. So ij are unit vectors due east and north respectively. Okay, that's normal. I goes to the east, so let's drop this direction as east, and this is north direction. So that's why the unit vectors, here is I, and here is J. Okay, due north. All right, so we set them up, and what we're gonna do, we're given velocities at time t0. The position vector of object A and object B are 400 i's and meters and 800 j meters. So what it means that it would set up the initial position for each object. Let's take that. We can say that for object A, it has 400 i's. So what it means, if you drop this vector on Cartesian plane, means from the origin, that every single position vector goes and starts from the origin to the position where the object. If object is here, it points to it. So that's why it's position vector. It defines a position. However, we have only 400 i's. That's for object A, and we can set up the initial position for object A, and also we do the same for object B. However, it's 800 j, so it means that it's twice more. Actually, I'm not going to draw to scale. However, that gives us understanding. So there are initial positions for each 400 and 800 meters for each object. So we need to find position vector of object B when it's due west of object A. So guys, we're not given any time for that, so that's why I definitely need to define the point of time when object B is going to be strictly due west of object A. So what it means? It means that somewhere here, let's say here is going to be object A soon at a given point of time t, and here is on the same line, so we can say that on the same level, horizontal level, that is going to be object B. Here is first position of the object B in a given time. So it means because they're traveling at the constant velocity and on the straight line, so it means what? It means that through some point of time, object B will be here. So this is basically direction displacement of object B, and object A is going to be here. You also can check those like not to scale displacements within the time just simply by doing what? Let's have a look. 59 and 20j for velocity of the object A. So here is somewhere 59 and here is somewhere 20j. So it moves that way. This is the resultant vector of displacement at a given point of time t. So through time t, through time period t, this object will be here, and that will, it looks fair because VA, both components are positive, so it goes that direction. So the same you can say about object B, because 20i, that's positive direction, negative 5, j is negative, so it goes somewhere here. Of course, the actual probably I need to draw something like this, but it doesn't matter. This not to scale, and it just gives you an understanding of what's happening, okay, over time. So conditions, let's go back to conditions, and we can say that, is it possible? Okay, no, sorry, it's not possible. Drop it here. Okay, anyway, I'll try. So the condition at a given point of time, their j components of their vector of displacement for object A is going to be equal to j components of the vector B, right? So if your set up position vector, not displacement now, but position vector, I just show you real quick. So if you set up position vector for B, it's going to be like that at a given point of time, and position vector for A is going to be like that. So both, you understand that j components, that's a vertical component, they're equal, right? Because actually the distance from B down perpendicular to their eastward direction or horizontal axis is going to be the same as distance from object A downward. So that means j components, that should be the same, and this is the base equation that allows us to find. So at given point of time t. So what we are going to write, we just simply need to write that two components from time, we need to set up the functions for position vector for R for the object A, and also position vector for the object B at the instance of time t. Okay, so generally I hope you remember, because we're given straight lines motion, but the main fact that constant velocity, it's simply linear dependency. So we can say that it's initial vector plus velocity times time. So that's, you can pick up from, physics for straight line motion, for motion along one axis, and also you can pick up from mechanics. So as if like each coordinate dependent linear like this, Vx component t. So actually you can write this is x component, in similar manner you can draw y components. But here we generally set up vector, position vector for the object A and for B. So initial vector R0 is 400i, so we just write it like this according to that formula, and on top of that we add velocity for A, which is 15i plus 20j times time. All right, and do the same for vector for the object B, for the position vector for the object B. It's 800j. Be careful with components, they're very significant when you write in equations. So here's 20i minus 5j, and just simply what we need to say, we need to say that this equality is fair, and this one for j components. So that's why we just simply track of j components. So j components is 20t here, so 20t is the coefficient before j unit vector, and j components here along with that for the object B is simply 800 minus 5t is the total j components for the vector RB. So what we're going to do, we need to equate coefficients. So we're taking just only coefficients, 20t and 800 minus 5t, and we equate. So that allows us to set up equation where we can find time. Okay, so 20t will be equal to 800 minus 5t. From where we can solve for t. Okay, so 25t is 800, so t is 800 over 25. That's how we can find the time moment or instance of time that will finally allows us to get that. So simply, it's 32 minutes, right? If we cancel that, I'll check real quick. Yeah, that's 32, not sorry, minutes, but seconds. Also pay attention to the units that are given. And t should be in seconds, right? Yeah, obviously. All right, so we've done that. We found the time. What we're going to do now, we're going to, maybe I can do it here. So what we're going to do right now, we need to find the position vector of object B. So that's why we just need simply to define RB. So finally, that vector that we're looking for, let's mark as that. And this is going to be position vector for B, for object B. Okay, so let's calculate. We have time, we just simply need to put RB, position vector for the object B, from time, which is 32 seconds. Okay, so if we plug that, we'll get, but let's do normally with components. So 20 times 32i, that's I components, and 800 minus 5 times, plus 800 minus 5 times 32 time, not time g. Okay, so we just simply plug into the formula. And now, let me allow to shift this a little bit, squeeze it back soon. And that will allow us to find the position vector when time is 32 seconds, which is 20 times 32 is 640 I, and also 800 minus 5, let's calculate that. 800 minus 5 times 32. Oh, the same component, however, yes, and it's positive as well. J. So we've got the final equation for the position vector, which you can see right there. So this is the answer, and because I explain in detail, it takes a bit more than I think 10 minutes. However, that's how normally you need to discuss and explain. If you like my explanation, I can do probably more video on this topic, so just give the comments. This was urgent, and that's why a little bit deviated from GCC, my major direction here. Okay, but I hope you like that. I hope you understand. If you check how I drew this, actually that works pretty fair, because 640 and 640, they're both positive components, and that means the general vector, position vector for B, RB, look like this purple arrow pointing in the position of vector of the object B at time instance t. All right, so that was my explanation for A-level mechanics. If you like, please put the likes, share this video who are still struggling with kinematics, And also, so I have a friend on my channel. He's actually doing A-level stuff, so please, also you can subscribe there and you find definitely lots more information. Just see in the comments below. That was Daniel Dallas. I hope you like that. Don't forget to subscribe if you're new. See you later. Peace.